Okay, welcome back. So this is P5. We're doing light and the EM spectrum in today's lesson. So if you remember from the last lesson, we looked at what reflection and refraction means, and essentially they apply to light rays as well. Okay, so here are the definitions for you again. Essentially, what is happening? Remember with refraction, if I go down here. If we remember, the light rays a series of parallel lines. Okay, one section, in this particular case, this section of our horizontal width is going to reach the air first and therefore travel a bit faster, and essentially it's going to rotate. Okay, whereas this section is still going to travel at the slow pace inside the glass prism, and therefore it will cause the entire light ray to rotate. Okay, and that's why it bends away from the normal. Okay, now we're gonna what these diagrams show us is total internal refraction, and there's something really important called the critical angle. So this is the angle where a ray of light doesn't refract anymore. It goes along the boundary between the two materials. So essentially the light ray comes in. So at this point we've got the critical angle here at 42 degrees, and essentially the light ray does not exit the glass prism anymore, and any angle greater than that critical angle, that light ray is going to totally internally reflect inside that glass block. Okay, so please make sure you've got this definition of the critical angle. So essentially, as I said, if the angle of incidence, which is this angle with respect to our normal line, remember the normal line is the imaginary line that is drawn 90 degrees to the surface where the light enters or exits the boundary of your between the two materials. Okay, so if it's at the critical angle, it's literally going to go along the boundary. Okay, if it's greater than the critical angle, we're going to get total internal reflection. Okay. So one use of TIR is optical fibers. Okay, so these can be used in endoscopes in medicine. Okay, so they can be sent through down somebody's body, down their esophagus or something, and basically we can send a light ray and it sort of acts as a mini flashlight. Okay, and signals can be sent back along it as well. Okay. Right, so just two sort of types of reflections that you need to be aware of. Specular reflection, so this is when you've got a flat surface, okay, and you can see the light rays reflect accordingly. With diffuse reflection, the surface is not straight, and as we can see, the angle of incidence is not necessarily the same as the angle of reflection in some of these rays, in some of these diagrams. Okay, so just please bear in mind, diffuse reflection refers to non-flat surfaces, and specular reflection refers to flat surfaces. So explain why smooth surfaces are the best to see a clear reflection. Well, because the parallel rays of light would stay together, so they still form an image. Okay, so a clear image, and it won't be blurry. So if you look at this diagram here, the reflected rays are not parallel. Therefore, the image that you see will probably be blurry or distorted in some way. So, other thing you need to be aware of, okay, you've got blue, red and green light. If they all combine together, we're going to get white light, okay? So a red object appears red because it reflects red and absorbs all the other colors, okay? So if you've got white light coming from your light bulb or some other source, okay, and then you look at a red object, that is the reason why, okay? That's why it appears red. Same thing for blue. Okay, it appears blue because the object reflects the blue light and absorbs all the other colors. If it's yellow, for example, it will reflect red and green and absorb the rest. Okay, so you just need to be aware blue and green will give you a cyan color, blue and red will give you sort of a magenta purple color, and green and red will give you a yellow color. Okay. Okay, so I'll just leave this table. Feel free to pause the video and just make sure you're familiar with the respective colors when you get a combination of the two. Okay, so we're now going to look at two types of lenses. One is a converging lens, okay, and one is a diverging lens. So if you look at these parallel lines, okay, so imagine we've got parallel railway tracks going this way, okay, towards the lens. Suddenly it all stops and slows down, okay, inside the glass, and it speeds up again, so we've got no change of direction here. Whereas if we look at this top one here, so we've got the parallel lines going like this, okay, this section of the parallel line will slow down first because it reaches the glass block first, whereas this section here is still going to be traveling at a fast pace because it's traveling in the air, which means it's overall going to bend like this, okay, and then same thing happens here. This reaches the air first, and that's going to continue to bend, and essentially we're going to get it moving in this direction. Okay, same thing happens down here, and eventually we're going to get what we call a focus point. And the focal length is going to be the distance from the midpoint of this lens to this focus point here. Okay, see, same thing happens here. Okay, the light ray comes in. Okay, this section reaches the glass block first, so that slows down, causes it to bend. Okay, and then it will bend outwards like so. Okay, nothing happens with this middle ray, as I've explained before. Same thing happens like this ray here. Okay, but what we see here is all the light rays are sort of spreading out, they're diverging. Okay, and if we retrace them this way, we see they come to a focus point to the left of the diverging lens. Okay, so that's the focus point here. So we will say this is a virtual focus point because it's actually, if we put a piece of paper there, we would not actually see that focus point, whereas if we put a piece of paper here, we would actually see the light rays focusing onto that point. Okay, so just make sure for your exams you've got the definitions for the focal point and the focal length memorized. So we're now going to look at how we can change the length of the focal length. Okay, so if we increase the width of this converging lens, this is going to move to the left. Okay, so it's going to be a more powerful lens. The same thing happens here. If we increase the difference from this point to this point, so we've got a greater difference in the width here compared to the width here, this focal length is also going to be moved to the right here. So we're actually going to decrease our focal length as well. Okay, so that's summarized here. The more curved the lens is, the more powerful it is. The less curved the lens is, the less powerful it is. Okay, so just make sure you've got these points memorized as well. Okay, so we're now going to be looking at how to draw these ray diagrams. So I'm going to start off with a converging lens ray diagram. So if we look here, and we know it's a converging lens by the arrows being pointing upwards like this and downwards. So these would be converging lenses, okay? And diverging lenses, the arrows would be inverted like this. Okay, but let's start off with converging lenses. So this arrow here to the left is going to act as our object, okay? So our object is obviously going to get some light from some external source, okay? But then that light is obviously going to be reflected in all sorts of directions. And in this particular case, this light ray is going to be reflected in this direction. It's going to reach our converging lens. So if we go back to this, so this is obviously what a converging lens looks like. So we've got a light ray coming in like this, okay? Now, the first rule is you draw a parallel line, okay, towards this horizontal line here, which passes through the midpoint of our converging lens. Okay, so you draw a parallel line horizontally towards the middle of the converging lens. Then the next thing you do with your ruler, okay, then you're gonna, and in the exam, if they haven't got it already, these points are the focal points, okay? So that's the focal length is obviously from this distance to that distance, sorry, from this point to that point and this point to that point. Okay, so once you've drawn your horizontal line there, you need to draw another line, diagonal line, through the focal point and just keep going on, okay? Then the next thing you need to do is, from the same top of the object, you draw with your ruler another diagonal line through the midpoint of your converging lens, and you just keep drawing it until you meet up with your first line that you drew, okay? And then simply you just draw vertically from this point where they interact towards this horizontal line, and that is where your image will be. And notice it is a real image, which means it's to the right. So if we put a piece of paper here, we would actually see that paper. However, it would be inverted, okay, it would be upside down. And also, as we can see visually, it is actually smaller or diminished, okay? So these are the three terms you need to be aware of, and this is the sort of terminology you need to be able to describe your image that gets formed, okay? Now this object obviously was beyond our focal length. What if we moved the object past our focal length? Okay, so here's that same object. We've moved it past our focal length. Let's apply the same rules. So again, we draw a horizontal line towards the midpoint of the converging lens with our ruler, and we draw it through the focal point, and we just keep drawing it like that. Then again, I'm going to draw it from the same top of the object through the midpoint or the center of the converging lens, and I just keep drawing it. Now notice they do not meet. So this time I've got to work backwards. Okay, so I'm just going to draw a dotted line backwards like so for this line, and then the same for this line. And then where they meet, I apply the same principle. I draw a line vertically to the horizontal line, and this time, okay, we can clearly see it's a virtual image because it's to the left. So if I put a piece of paper here, I would actually not see it, okay? It would not project onto any actual object. But I would see it if I was going to look from this way. And this is how magnifying glasses work. If you think about the distance that this object is to the glass, well, it's a short distance. So when you're looking at text through a magnifying glass, that's why it appears to be magnified, okay? How else can we describe this image? Well, it's upright, okay, compared to this one previously. This one is actually upright. It's also magnified. It is bigger, okay? So again, these are the sort of terms you need to be able to describe the image with. And finally, let's describe how a diverging lens works. Okay, so again, we've got an object here. Here's my focal points. So again, I draw my horizontal line to the middle of the converging lens here. Then with my ruler, I need to work backwards this time. Here's my focal point. Okay, so I'm going to draw a dotted line towards the top here, and then I'm just going to continue to draw it upwards like this. And then the same rule applies from the top of the object through the center of our diverging lens. And look where they meet. Well, they meet here. Okay, now again, this is going to be a virtual image. It's to the left. I can't physically project this onto a piece of paper or a screen, so that's why it's a virtual image. Also, it's going to be upright, okay, and it's going to be smaller, as we can see there, okay.